So welcome to the Wednesday morning session. It's a pleasure to introduce Professor Pranay Goel of the IISER Pune. Pranay did his PhD in 2003 from University of Pittsburgh, right? And is an expert on physiology. More after that in diabetes modeling, and more recently in machine learning methods. And he will tell us about deep learning using Pytorch.
Oh, I have my mic, right? Thank you, Gautam. Very kind introduction. I want to start by thanking all the organizers, Rahul, Leelavati, Gautam, and the others for inviting me here, and especially for organizing this excellent meeting, excellent program at ICTS. So, I mean, as Gautam said, I've been getting into machine learning, and I'll tell you a little bit about the work that I do. But what I want to do for the hours that are pedagogical and culminating in the hands-on session, I wanted to bring you up to date with writing your own little Pytorch code and trying to run it for various problems. Okay, so I will tell you what that means a little bit later. I'll start by walking you through Python, the essential features of Python. So I'll tell you in a minute what that means. Then I will follow it up by talking to you about Pytorch and how you recognize some of the things that we do in Pytorch for deep learning. Okay, and then finally on my third talk, we will have a hands-on session, which is going to be a bit challenging, but I will try to walk you through an example exercise that you can do for yourself. Okay, so that's the plan. If at any point you think that you want a different sequence of events, please feel free to contact me during one of these breaks that we have, and we'll all find out alternate routes possible. Okay, so what am I going to do in the first part? So we have a huge lot of things to cover. So clearly I cannot cover them all in one go. I'm going to give you essential pointers to where you should look for what and how to get up to speed and running, right? And that usually takes several months. When I ask a grad student to start working on a problem and they start doing it, it usually takes a couple of weeks to get the first things going, and then a couple of months to get a little bit deeper into it. And then, several months down the line, you start discovering that you knew very little and so on. That's okay. What I'm going to do for you is I'm not going to describe all the very basics of Python to you. I'm assuming you are smart enough and you can pick it all up on your own. Okay? I'm going to go in and help you with the parts that are slightly more difficult and the parts that are actually more used often. If you understand the structure of a Pytorch code, then I think the job is half done. So what do I mean by doing that? Oops, this keeps going off. Okay. So how do I plan to do that? What I'm going to do that is I'm going to give you a reference to a very nice and very interesting MIT OCW code. It's OCW course. This course is an introduction to computer science and programming in Python. I encourage you to go through this on your own. There are YouTube videos. Everything is Creative Commons license. There's some lovely videos. Usually this stuff takes about a semester to cover. So, there's slides and there are videos and all sorts of additional material. This is a nice course which will help you understand all of the basic stuff in Python. What is the basic stuff in Python? You have to know about types, you have to know about variables, you have to know about functions, you have to know about what else? Conditionals and all of the stuff that you already know from other languages, right? So there's no point in me trying to redo all of that for you. I'm sure you can pick it up very quickly. All of you are very good experts in programming and so on. As a show of hands, how many have coded in Python before? Everyone has coded in Python. Okay. How many are very comfortable with classes and objects? That dropped to half. Okay, so what we'll do in the first classes, we're going to revise Python classes and Python objects and all of the stuff that is associated with that, such as inheritance. Okay, so those are my 3 topics I want to cover for the first class. Then in the second class, my second lecture that I have, I want to talk about Pytorch itself. Okay, so the first class is sort of an overview at an advanced level of Python, but none too advanced for you folk. Okay, these are the acknowledgements. I want to state them up front. These slides are available from that link over there. The course is 6.0001. Fall 2016 is what's listed on this slide, but I'm not sure if they have more recent versions that you would like to listen to. Introduction to Computer Science and Programming in Python. The instructors are Dr. Anna Bell, Professor Eric Grimson, Professor John Gutag. So I believe the slides that I'll be using are due to Dr. Anna Bell, but it's part of this course. And you can find them actually on this link over here, lecture slides and code. Okay, so let's start talking about object-oriented programming in Python. Anybody want to have a question before we begin? No, let's start. Okay, then. Okay, so I'm going to talk to you about object-oriented programming, which is lecture 8 of this course, and Python classes and inheritance, which is lecture 9 of this course. Okay, why do I want to talk to you about these two topics? Well, Pytorch code is going to be very, very deeply invested. Did I lose this? Is it still on? It's going to be very deeply invested in classes, and you are always going to inherit from classes, and you're going to write your own functions. Sometimes you have to override functions, all of those things. So if one doesn't completely understand the structure of how these things are built, it's going to be a little bit harder to understand how Pytorch code is structured. So let's go over this and spend some time on it. If there are any questions, we'll be able to sort them out, I hope, during this presentation. So let's start. So there are many native types of data that are actually part of Python. So you will recognize this as an integer, that's a floating point, that's a string, that's a list, and so on and so forth. This is dictionaries. So each one of these things is an object. And I want this to be an interactive session. So if you want to ask some questions while we are going along, this is all revision for many of you. So if you want to ask any questions, please go ahead and ask. Okay? So each one of these is an object. So an object is a very, very basic type, very, very basic structure in Python. And each one of these has a type, right? So just the fact that, you know, these are different kinds of objects is represented by its type, a string or an integer or a float and so on. Okay. So now what's an object? An object is going to have an internal data representation and a set of procedures for interacting with that object. Okay, so this is going to be a very basic definition for us. And we will elaborate on this definition so that we understand better what this behavior is. So when we talk about object-oriented programming, you want to have a set of data and a set of functions. If you believe a car is an object, okay, then what might it represent? Well, if you have an object called car, what might be the data that's associated with it? For example, you might want to talk about the color of a car. You might want to talk about the mileage that car gives and so on. Okay, so those will be the sort of data that represent the car, but you can have other representations of a car also. The functions are going to be the ways in which you interact with that object. Okay, so a function is going to provide you the class interface or an object interface. All of this is, let's just stay with it intuitively for a minute, and then I'll make this more elaborate. When we get into examples, you'll be seeing this much more clearly. But very broadly speaking, it tells you how you want to interact with that object. Okay, so we'll discuss also in a minute why things should be this way and what are some alternatives and so on. Okay, doesn't always have to be this way, but this is the way Pytorch is built. So we are going to focus on objects. Okay, so an object is an instance of a type. I'll get to I'm just flashing this word instance over here, and then we will get into what an instance means. Okay, so everything in Python is going to be an object, and we are going to create new objects. We are going to manipulate objects, and we are going to destroy objects. Okay, so that's pretty much what variables do for you, right? So think of an object as a generalization of a variable, but it's much more than a variable. Okay, so we're going to see exactly what that means, that it breaks down into these things. So objects have a data abstraction, an internal representation, and interface. Why do we need an internal representation? Well, we need an internal. We have an internal. We want to supply an internal representation through what are known as data attributes, right? And we want to provide an interface for interacting with the objects through what are known as methods or procedures or functions. These are all the same thing. Okay. Okay. So all of this is, I've gone through it very quickly. Now let's back up and try to understand what all of this means. Okay, so let's talk about it. What I'm going to describe for you is essentially this structure of having a class and having an instance of a class. Okay, so let's talk a little bit about what lists are. How many people can describe to me what a list is? Just quick show of hands. I don't mean to quiz you. Okay, so anybody want to suggest what a list is? Okay, so those of you who said this is a collection of objects are looking at it from a user perspective. That's how I think of it, as providing me a sequence of objects, right? What about a programmer who actually wants to code the list? You know, I want to be a programmer who allows you to create lists of the type that are reflected in your mind. There's going to be a communication gap between the two of us, right? I, as a programmer, want to describe a way of describing lists. And maybe I think maybe lists should be, read backwards. And you will say, well, no, that's not right. List should be read forward. And, we get into, if not an argument, at least a gap between our understanding of what list is. How do we resolve this? I agree. So we can come to a point where we agree on what a list should do. We can have a conversation and we can come up with what a list can be. But tell me, how does the programmer implement the list? What do they have to think about? You have to think of some things. So we've just discussed that we can agree on the functionality what a list should provide, a list type should provide. Which position, which object should fit in. Again, so is that a user perspective or is that a programmer perspective? I'm trying to have this idea conveyed to you that the programmer perspective and the user perspective are different perspectives. Data type. So what's a list going to do? A list is going to have one number. Let's say it's a list of integers. You're going to have one number, you're going to have a second number, you're going to have a third number, and this collection somehow I'm going to call a list. I'm deliberately keeping it vague because of this idea that, up front, we might have different ideas of what a list should be.
I think what you have shown as a linked list is how it is done in Lisp and Scheme and so on. But
yeah,
I'm pretty sure in Python it is not represented like that. It's a pointer array.
You're right.
Yeah,
probably.
Yeah.
So, I mean to say that different lists could be represented in different ways.
Right. Okay. Yes. So it's a pointer array, I think. Anyway,
yeah. Okay. So, is that a user perspective or is that a programmer perspective? Okay, so eventually we're getting closer and closer to this idea that the programmer wants to describe that if I provide you a list, I'm going to provide you with certain functionality and the user agrees to use it or not based on what the functionality provided is, right? Is that okay? And then the details of how a list is implemented inside is actually left up to the programmer themselves. So the programmer has to provide you a specification. For example, you might represent a list internally one representation of a list is, of a linked list, is to say that I'm going to provide an actual data and a pointer to the next data. Okay? And somebody else might choose to do it differently. For example, they might choose to use a previous package on which they want to build things and so on and so forth. Or there might be a very domain specific application where a linked list might mean something very specific to that domain. And there might be, so there is this idea that in order to be able to manipulate lists, to be able to call it with an index, to be able to calculate, for example, its length, its minimum value, and so on, it'll work. All of these kinds of functions that are provided by the list documentation, they will be implemented internally by the programmer themselves. Okay, the internal representation should be private. It's up to the programmer to decide what internal representation they want for the list. Okay? What they're providing you as a user is going to be the the specifications of the functions they've provided. Okay, so this thing will come back to when we use Pytorch. There are certain functions that are there'll be functions, there'll be packages, there'll be modules in Pytorch, and there'll be certain functionality, let's say, that will be provided by the Pytorch package. And our job is to know how to use it correctly. If we adhere to the specifications that the functions are provided, that the functions are written in the correct way, if we adhere to that function, that API, then we will get the right behavior. If not, we have to go back and figure out what exactly does the programmer want to do and whether we're doing that. Does that make sense? Okay. The correct behavior may be compromised if you manipulate the internal representation directly. So you're not going to handle the internal representation, even if it's available to you. In an ideal setting, the internal representation will not be available to you. But what Python is, the Python being what it is, it allows you to manipulate things inside a class object, and that's not a good thing to do. So it's just considered bad, but it is possible to do. Okay. So what are the advantages? Well, you can bundle things into packages, right? So Pytorch is going to provide us with the package, and a package will be provided with several modules. I'll describe what modules are. There'll be sub-modules and so on and so forth. And based on all of this, you're going to use these functionalities that Pytorch provides, so that that avoids you writing all of the basic stuff yourself. You can just simply use the functions that are provided. Okay, so now let's talk. Is that clear? So we're going to have internal data representations, which sort of represent how the class is, how an object is going to be manipulated. And we are going to have an external facing function specification of how that class should be approached, so to speak. Does that make sense? Okay, so we're going to use this in Pytorch later, but let's try and understand why this is a Python functionality, and Pytorch functionality is essentially adhering to Python functionality. Okay, so let's create a distinction between creating a class and using an instance of a class. Now, creating a class is probably a programmer side job, and using a class is probably a user side job, right? So creating the class will involve defining the class name and defining its attributes. So you want to have a class name to begin with, right? For what class you're going to use. And you have to have certain attributes. So when I say attributes, remember that a class object, that an object, I have not yet been completely clear what the distinction between a class and an object is. Okay, I'm trying to come to it in a minute. So I just changed the title over here from object to class. Now class is a template which will adhere to this basic structure. You have to have some data. Those will be called the data attributes, and you have to have some functions, procedures, and so on. Okay. Now some of these functions will operate on the data inside the class. Okay, I don't need to know outside the class. The person doesn't need to know what is going on, and the manipulation is internal. Some of these functions will be specifically for saying, find me the data attribute such and such of this class. For example, I might be able to say, here's a class called car, and one of its attributes is, one of its data attributes is color. It's a brown car or a purple car. Okay, and you can have a method that says, find me the color of this car or this particular car that I'm talking about. Okay, and that it's the responsibility of the programmer to return the right color, to return purple. So these methods are called getters. Then there could be other methods which are called setters, which say, well, you've got your car set to be purple. Why didn't you set it to be yellow? So I'm going to set it. So setters and getters are two kinds of functions that allow you to manipulate data. Rather than accessing the data directly, you want to have a getter and a setter that allows you to access it. Getter and setter function. Okay, so that's just an example of how you interact with the data inside a class. Now you don't want to, the idea being in good object-oriented programming, you don't want to access the data directly, because the internal representation of the data might change at some point if the programmer decides to. I'll give you an example. An example is, so clinically, very often age is represented by a variable age, often. Okay. But its units could be months, it could be years, right? So even though it is age, its internal representation in terms of years or in terms of months could change at any point depending on what the what the conventions the programmers are using at some point and so on. So when you want to ask for age, it's best to go through a getter or a setter method rather than directly manipulate some age variable, what you think is an age variable. Like one of the age variables inside the class, you might know that it's called years, so you go ahead and manipulate it. But at some point, the programmers decided to use months for their age, but they kept the variable name years itself. Okay, so those kinds of things can happen. Internal representations can change, so it is best to access them through functions that are specifically designed to get and set internal data. Okay, that's going to be an important point for us. Okay, let's talk again a little bit. We'll get to that point a little later. Let's talk a little bit about how do you use a class. Okay, so here's the idea that I was trying to get to, but I sort of hedged around it. A class is a template for creating objects. For example, if I have a car template is going to have, say, the color of a car. This is a data attribute, and I might have some get color, or I might have mileage. But now from this template, I want to create several cars: car 1, car 2, car 3. Okay. Now you can, I'm using car, but you can easily think of this class as defining patients, for example. Okay. Now, what do you think is the relationship between this template and individual cars that have been created based on this template? Quick answer, anyone? The template contains? So, anyone else? Yeah, so instance, right? So an instance, this is the class and this is an instance. And the relationship between the two is a car 1 is a car. Okay? There are different cars, all of which are templated on the class car. So each one of these cars will have their own data attributes and function attributes that are exactly these. So car 1 will have a color, car 1 will have a mileage, it will have a getter method called getColor, and so on. Okay. I might be able to change what the attribute is. So one car may have purple, another car may have red. They're both the variable color equal to red, color equal to purple. Okay, does that make sense? So individual instance, these are called instances. These are objects. This is the template, that's the class. So more correctly speaking, this is an instance of this class. This object is an instance of this class. Okay, why is this not coming up? Yes, so the type is the class, whatever name this is. The class is of, the type is car. That class type is going to be car. Is it only here or Rahul? I don't think I'm able to see this. It's there on my screen. Can you guys? Screen share is not working because it went into blanking mode. Oh boy. Zoom died. Sleeping mode. I'll prevent it from going. Thank you. Sorry for that. Okay, so is everyone clear what an instance is and how it relates to a class? Any questions? Because this is probably the most important, one of 2 or 3 most important topics or ideas. Yes. Right. So this, yeah, go ahead. Yeah. So we are creating objects. If I had created an integer variable v1, I would have created an object, right? So the moment I create an instance of a car, I haven't actually showed you how to create an instance of a car. The car is the template. The moment you create an instance, I have created an object that is of type car. And it has all of the same, it carries the same template as the car template does, but its individual data attributes can be different. And there's a cell. The class is the blueprint. Okay, the class is the blueprint for how objects should be created. Yeah, by columns, I mean the column title. So all columns sort of represent a common function, common behavior, common functionality, etc. I can create many columns of each one of them, and I can call those columns different things like K and L and M and so on. They will all be templated on the class column. So all of the functionality that's provided by the car functions, car template functions, the class functions, all of those will be available to each object. Does that make sense? So we're going to have to decide how to create an object of a class. Okay? That's one of the jobs that's going to be. We're going to have to think about this from both the user perspective and the class creator objective, because here is where things get a little entangled. Okay, so here's how we create a class. To define your own class, you're going to use the keyword class. That's called a class definition. Okay, this is the name. This is a name, coordinate. Okay, so here what the author wants to do is define a class which is going to take 2 numbers. Think of Euclidean points. Yeah, think of points in a plane. It has some x and a y. So one number and another number. That coordinate class is going to take a pair of numbers and allow you to do certain things with it. For example, I'd like to be able to add vectors on the coordinate class. Suppose I want to be able to do that, then how do we define it? Okay. So if you recall how functions are defined, then this is very straightforward for you. The problem is, I mean, the difficulty is with this object over here. We'll get to that in a bit. But all classes take this as the parent class. The parent class of all is object. Okay, and then you define attributes inside the class coordinate class definition. No, you don't. I will get to this a little bit later. I'm deliberately being a little bit easy about it. The base objects, this is an idea called inheritance. You're going to derive an object. You're going to derive the class from something called object. Okay? Object is the very basic object you can have in Python. Okay, so don't worry about this object for a minute. You won't need to use this object. Think about everything else except that. Okay, if you want to discuss more about this, you can come afterwards and discuss with me offline. Okay, now this placeholder says now define all the attributes, whether you're defining data attributes or you're defining functions, you can define that inside. So what I'm going to do, so what one has to do is, once you define the class using this syntax over here, you're then going to define a certain set of data attributes, and you're going to have define a certain set of procedures which will be provided by that class. And that's what this slide says. You want to define some data attributes, for example, a coordinate made of 2 numbers. So if we want to define a class called coordinate, we're going to have 2 numbers that we are going to supply somehow, right? It's going to be composed of 2 numbers, the x coordinate and the y coordinate, right? So if somehow our data will have to have 2 values inside, 2 data, one corresponding to the x, one corresponding to the y, and we're going to have to define some way of, we're going to have a means of working with this. And then you want to also define some methods. For example, you might define a distance between 2 coordinate objects, but you know, if you just have 2 numbers, there's no meaning of distance between them. If you think of these 2 numbers as being part of a tuple, and you want to take another tuple, and then you want to take the Euclidean distance between them, then that's what a distance would be for Euclidean geometry, right? So you would have to define that as part of your class, that my class allows me to compute the distance from another coordinate object. Okay, so that is an example of a method that you're going to have to define as a class author. Okay, so the other side of things is, this is how you define a class. The other side of things is going to be a little bit more interesting to us. How do you use a class? So Pytorch is going to make available to us many functions and many classes that we're going to use in our own code. And we're going to have to create an instance of an object. Okay. Okay. So how do we do this? Well, the class coordinate has this special function called init. So this init function, this is again the template. Remember, this is the class. You recognize this keyword class, right? So this is the template for the coordinate class. And there is a definition. So this def corresponds to, does anyone recognize what this def is? Was functions, right? So you're defining a function, and this is a special function with 2 underscores. So this is called a double underscore function. It's a dunder function. Dunder is a shortcut for, these are special functions that you have to define. In particular, this init function is called, it's the first thing that is called the moment an object is created. So whenever in class object is going to be created, this init is going to be called. Okay. So we have to know what will be supplied to this class. What do you think will be supplied to the class as class parameters? What? X and Y. If you want to create a coordinate, and if you want to use a syntax that says syntax like coordinate, that's the class name. Say I want to do it with 2 and 5. So I supply 2 and I supply 5, and I sort of imagine that this is going to be X coordinate and that's going to be the Y coordinate, and we can agree that that is going to be our convention. But you notice that you're supplying 2 numbers to it, right? So those are the 2 numbers that are that are supplied over here. So let's parse this. Okay, so I said that this is a special function called init. Init function is the function that's called at the very first time that the class object is created. So it's called the constructor. It's the entry point into creating an object. Okay, that's a keyword that says this is a function. Now this I'll come to in a minute what it is. These are the two data that are supplied when an object is created. So when I create an object, I say C1 equal to coordinate 25. I'm saying create an object, create an instance of coordinate class. That object C1 is instantiated, is initialized with two data, data 2 and data 5. The data here I recognize implicitly to be X, and the data point here I implicitly recognize to be Y. How do I know this? That's the class API. That's the class interface that is supplied to you. That's documented. That idea that the idea that this is not switched around, this is not Y and that is not X, is provided to you by the class interface specification. Does that make sense? Okay, so the X and Y are passed as parameters to the init function. That seems reasonable. What's this beast called self? This is idea number 2, most important idea number 2 of this class. What is this self? Can anyone guess? Maybe it's not a good idea to ask to guess. It points to itself. Okay, so whenever we, so this init function always requires self. Self is a placeholder for the instance of the class. That's all it is. Let's repeat it. The self is a placeholder for the instance of the class. I have created an instance of this class. The self points to this object, this instance. Okay? So the first of these, it says, whenever I'm going to create a coordinate object, for that object, the constructor will take the first argument as that object itself. That's self. And then for that object, now you understand why this line is written over here. For that object, the instance object, I use a dereferencing operator dot x. That object's dot x will be the x supplied here and place it there. So you see why this is confusing. This variable corresponds to, there is a difference between this x and this x. What is this x? The one that is the function argument for that is passed when creating the object. Okay, and this x is the internal data representation of data of dereferenced of that object. It's the x. So I could have called this something else. I could have said self.x coord is equal to x, where x will be the one that's passed through from the function list, and x coord will be the internal data representation of the x coordinate of that class. Does that make sense? So we will see this self appear over and over again, and I don't want you to get confused because many do of what the self is. Self corresponds, it is a placeholder for the instance of that class that is being referred to in that moment. Okay, so self is a, okay, let's not get there. But do you see why you needed to create self? Can anyone say why we needed to create a self? Another variable. Self is that's right. But can anyone say this different? Why do we bother with self? Why don't I just write x coord equal to x? We're done with it. Easier syntax. That's right. So if there are different instances, each one of them will have their own x and y, right? I might create a coordinate with 2 and 5, and I might create another coordinate object with 3 and 7. I need to be able to track the class that the object C2 has a different x coordinate than the other guy, right? So if I create another This object, what is the x corresponding to this object? If I do C2 dot x, dereference this object's x coordinate, what is it? 3. And if I did C1 dot x, what would that be? 2. So you see why you need that self to reference that you're pointing to that particular object that you're working with, right? Now, you might ask, you can ask a little bit more complicated questions, but we can do that offline, right? This is the basic idea. I'm talking about the data attributes that correspond to that particular object of that class instance, class that you have created, that particular instance. So I'm assigning X and Y to the instance data variable, instance data. Okay, that's why you need it. And that X, of course, comes from the parameter list. So you supply it. In Pytorch, this is going to be important to us. We're going to have lots of these functions going around. And whatever you want to supply, let's say there's a built-in function in Pytorch, and you want to say model.train. Now model.train, model is my model, train is going to be my training function. I will have to supply it a certain set of variables. Let's say I want to supply it train with a learning rate of 0.001, or if I can, or I can change the learning rate to be 0.1. Learning rate is something that my specifications understand, that my the learn function recognizes or something like that. But I will have to supply it the value. I will have to supply it the learning rate. Should it be 0.1, 0.01, 0.001, and so on. So clearly you're going to have to you have a need for supplying parameters to functions from the outside. So what comes in from the outside is essentially the specification over here. Okay? This is what the operations are inside operating on that instance. Does that make sense? Okay, shall we move on? Okay. So we've gone through this. Okay, so let's go through this set of slides. What is a method? A method is just a function, right? A method, procedure, function. These are all different names for the same thing. It's a procedural attribute. It's a function that works only with this class. Okay, so it's a class. You supply certain procedures, certain methods that are attached to this class. Like it does not make any sense to supply division of coordinates. So you don't supply that function. It makes sense to add 2 coordinates. So you supply that function. And when I say supply, I mean as part of the class creator, that functionality is built into that class. Okay, so the dot operator is used to access things. So I have written that down here as well, just to remind you that the dot operator is used to access any attribute. It can be a data or a method of an object. Both are dereferenced by the dot. So you'll have the class name dot. You can either put a function there or you can put a data object. Okay? So that dot is a very powerful thing. You will see often things like torch dot nn dot, I think util dot data loader. I might have got the syntax, but you will see several dereferencing that's going on. The dereferencing symbol dot is a very powerful system. It tells you where to look for that particular functionality. The function we are interested in is, let's say there's a function called coordinate. Let's say there's a function called add that I have supplied inside coordinate. Then I will say coordinate dot add in order to get the add function corresponding to the coordinate class. It's not any old add. It's the add function that's defined inside the coordinate class. The coordinate dot add will be the syntax. Does that make sense? Okay. Okay. So here's a little exercise. Let's say they've defined a function for a function called distance, and it takes in 2. So that we've seen this before. There's a new function called distance. This was a dunder function. This is a function that's defined by the author. So it starts with distance. This function is called distance. That's the name of the function. The first parameter is called self. Again, it's used to refer to any instance. It's a placeholder for an instance. And this is another parameter to this method. So that's the second argument of this function, right? And then you can see that this set of operations is actually taking the self.x, self.y, and taking the other.x and other.y, and it's computing a standard Euclidean distance. And that's the functionality of this system. Okay. So how do you use a method? Well, here's an example of using methods in two different ways. Well, you can use the distance function. You can supply it with an argument. Now, for those of you who will notice that the self was not actually supplied as a parameter. And you might ask, the self was one of the first argument. The first argument was self, right? But self was not supplied when distance was called. So this is C dot distance. What that means is this is an object C. Its distance, the name of the method, right? And because C is of type coordinate, therefore, when you dereference, when you apply distance to that C, it is actually the coordinate distance. It's the distance function of the coordinate class that is applied to C. Okay, this is a bit of a shortcut that Python allows you to do. And the second argument is 0, which is a different coordinate with x and y coordinates 0, 0. But notice that self is not supplied. So self you can omit. Very often self will simply be omitted in the parameter. Okay, so self is implied to be. So self, what is self in this case? C, right? Because we're operating on it. I'm this object. This is 0 is an object, yes. This is the instance of a coordinate type. This is an instance of a coordinate type. Okay, so you can see that here, right? This distance, because you've applied it to C, if the coordinate class implements a function called distance, the coordinate class function distance will be applied to C. It takes in a parameter list, which is also of coordinate type. That object is passed as a parameter as an argument to the function. How did we know this syntax was supposed to be this way? Because you went back and looked. That is the definition of the function. So you have to adhere to the function definition. Yes, because that's what the specification expects it to be. When you're supplying 0, the function class distance expects a type coordinate in the second class, in the second argument. Okay? That's the function definition. C comma 0. So I wonder what would happen, but I imagine that you would ignore that. C comma 0. C comma 0 would be fine. I think. Yeah, it should be. I'll have to check that. There you go. Right, thank you. So C is it's an object to the call. C is the object that you're going to call. C is self. Okay. You can use the distance function from the coordinate class and call it with two explicit arguments. The first argument is the object C. The second argument is the object 0. You use it here. It's a distance function inside coordinate class, defined by the coordinate class. Does that make sense? These two are equivalent methods, equivalent ways of going about it. So there's an important, this is going to be important in Pytorch also. I will point it out if I remember to. You can actually take a function, or you can send it. Sorry, let me back up. The dot applies to both functions and data attributes. Okay? So it's up to you to decide what it is applying to. Okay? Functions will be recognized by the parentheses. Data most likely will not have parentheses. Okay, I don't need this. I will go to the next set of slides. Any questions before we jump into inheritance? So the next important idea that I want to talk about is using a parent class to derive a child class. Let's go. I want to go, should I need, you can go through all of these in detail on your own. And if you have any questions, I'm happy to answer them. Okay, so I'm going to talk to you about hierarchies. So you can always take a parent class. When I say a parent class, I mean a class, and I can create a child class out of it. So what does it mean to create a child class? Let's say we want to create a hierarchy that I want to create animals. I want to create a class called animal, right? And then I want to say, well, the class animal, some of the animals I will allow them to be people. Some of the animals I'd allow them to be cats. Some of the animals I'm allowing to be rabbits. They're all animals. So they will all inherit all of the properties of the class animal, how you defined it. Okay? But some animals will then be specialized to people, some animals to cats, some animals to rabbits. So what would this entail? Any suggestion? What might this entail? What would you have to do in order to preserve the animalness and then allow for that animalness to have its own individuality in terms of people or cats or rabbits? That's right. Was there another answer? You will have some local attributes and you will have some global attributes, right? So all of the things that the parent has, the child will also have, right? But the child may have its own modifications of some of the things that they are inherited from the parent. Is the idea clear? Okay, so let's see. The parent class can be a, let's say animal is an example of a parent class. So let's call this a super class. It's the guy at the top, right? And every child class is a subclass. A subclass will be a person or a cat or a rabbit. These are all subclasses, but they're all inheriting from the parent. All these children classes are inheriting from the parent class, right? So what does that mean? That means it inherits all the data and behaviors of the parent class. It can add more information. It can add more behavior, or it can override behavior. So let's go over this carefully. The syntax will be pretty straightforward once we realize what we have to do. In order to create a hierarchy of classes, if I want to create a child class, then by definition, all of the behavior of the base class, of the parent class, is going to be available to these. Now, each subclass can say, I am a child of the parent, but I want more. I want to add more information, or I want to add more behavior, right? So I might change the data attributes, I might change the functional attributes. Or I might say, let's retain the same functions that my parent has, but I'm going to redefine what that function is going to be. Okay? So for example, a function speak. All of these can speak, the person, the cat, and the rabbit. The sounds they make are going to be different. So the speak function, if it's defined as part of the animal superclass, it's going to be tweaked to say meow in the case of the cat. So it overrides a function speak is overridden. Okay. A person class may want to implement some functions like social network. I want to have friends. I don't know if cats and rabbits have friends or not, but probably not. So that might not be a functionality that's rather relevant to a cat subclass. So each class is derived from the base class. Each child class is derived from the base class and can do one of three things. It can add more behavior, or it can override behavior, or it can add more information. If we remember this, then I think child classes will be straightforward for us to go through. Okay. So let's take an example of a parent class animal. Let's see there's a whole list of functions. So this is our class constructor. This is just an exercise now in reading class definitions, class specification, right? So this is the keyword class that tells us this is the class specification. The class name is called animal. Object, I said, is a base class from which every class is derived. This is your constructor, right? Notice, how do we know that? Because that function, which is described by def, is a dunder init function. So it takes self, and it takes in this parameter, this argument called age. Self.age, so age is an attribute of the self class of the animal class, is this value over here, age. There's another variable over here, self.name. By variable, I mean data. self.name, name is something that's attached to as one of the data attributes of this class, and that is none. Okay, so you can also have, so notice in this example over here, the parameter list was shorter than the number of attributes. You're going to see this in Pytorch also. You're not always going to supply the whole list of, learning rate should be this and batch size should be this and so and so and so and so. You could have had a lot of parameters, but you only supplied a few. Okay? And that's because there are default values that are often attached to, maybe I'll just take a few. Okay? There are default values that are attached to, and then there's a whole bunch of, to some attributes. You can go through this yourself. There's some getters and setters that have been implemented. Let me show you a subclassing. How does subclassing? Okay, so this subclass class is going to be called cat. Cat is a subclass of the parent class. Now that parent class goes in as animal. Okay? That's what goes into the class definition itself, right? So we know now that the class cat inherits all of the attributes of animals, all of the stuff that we saw on the last page. And everyone okay with that? Yeah. And there are, this is a function called str dunder that basically says if I want to print the class, what it is, put it in some nice format. Okay, so ignore this for them. This is a new functionality, okay, that's added. So in all the previous stuff that we saw as part of the definitions of the class animal, there was no meow, there was no speak. So the cat decides to implement new functionality by defining a function. That function is going to be called speak. It takes in self and then it prints meow. Okay? So this function is called on cat, it will print meow. Can we have an init function? Well, the init function is inherited from the parent class. If the init function is not explicitly defined, it inherits from the parent class. You will see an example of that later, where we'll create an init function that calls the init of the parent first and then adds more functionality. Okay? So that when just like self corresponds to the object itself, its parent is called super. When you'll call an instruction, you'll call an init constructor from inside a subclass. If you need to call the parent constructor, you will call it using super and then whatever else. Okay, so these are just examples. So I'll stop by showing you this last slide over here. The object-oriented programming model is used extensively in Pytorch. Okay? You create your own collections of data, you organize information, and you provide division of work. You will see all of this being implemented very much in Pytorch. You get access to information in a consistent manner. So Pytorch is a library, and if different people use Pytorch, they will all access it in the same ways. You can add more and more layers of complexity. We will see an example of that. You add more layers of complexity. If I want to build a neural network with say 3 layers and someone else wants to build a neural network with 25 layers or 2500 layers, well, that's an example of extending, of being, of creating layers upon layers of complexity at the user level. And so that has to have a correspondence at the class, at the creator level, and that is all provided by object-oriented programming. So like functions, classes are a mechanism for decomposition and abstraction programming. You can look up what these words mean by going through this course, and you'll get a much deeper understanding of what decomposition and abstraction mean. It's essentially these. You want to decompose things, and you want to abstract away the essentials to get working objects of a given class. Okay, any questions? In the next class, I will take an example from Pytorch and walk you through very simple Pytorch construction. Please, you need a mic? Okay. That's a very general question. I'm not quite sure what you're asking, but if I understood your question correctly, well, essentially you create data in data locations. You store certain bit strings, right? And everything is based off of that. Now, each language will provide you different data abstractions. Each language will provide you variables of a certain type where you can store a certain type of information. For example, if you store a variable of type int, then you can store only integers in that location. Whatever is stored in that location will be interpreted as an integer. That's basically essentially how it works. Okay. Oh, so that memory location is freed up to be used by something else. That's all it means. Vanished. Void. Nobody can access it anymore. Garbage. There are these things called garbage collectors in languages. What does that mean?
More of a hardware and systems question, not a programming question. So you can read about how a computer is organized, and there is something called memory, where there is volatile memory, which is RAM. When you say you have an 8 GB laptop, that is the RAM. When you say you have a 0.5 terabyte hard disk, that is storage. Your data frame, when you assign it, lives in your RAM. When you delete it, there is something called virtual memory. Your operating system manages that. So it handles what variables are placed in what parts of the memory. When you delete your data frame, that part of the memory is freed up. So your operating system can use that memory for something else. It is like a piece of paper. If you erase the blackboard, where has it gone? It's just gone. It's like that.
That's a good answer. Any questions on Python?
Yeah, I think let's take this offline.
Especially if you want me to go over any of this, we have a few minutes. Do we? Any of the syntax you want me to refine? Getter is a method and a setter is a method which allows you to access your data in an object, in a class, but you are making an explicit call to get the data. You can just get the data. I mean, you can just say c.x. You should not do it. You should say, please give me x, or please change x. That's a getter setter. Can you speak louder, please? Yeah. Self is a Python keyword. Yes. Is that, I'm not sure what the question is. Can we change self to something else? I don't quite remember the answer to that. I believe you can, but self is just so commonly used. The moment you write self, everyone else knows what you're talking about. So self is, I mean, that's sanitary practice to use self. Possibly, yeah. Yeah. Possibly, yeah. Those things can be looked up. I mean, yeah. Any other question? So, okay, so let's close here. And when I come back and show you Pytorch code, I'm going to walk you through code, and I'm going to quiz you on what some of these things, whether you recognize some of these things that show up in the code. Thank you.
Okay, thanks everyone. Before we break for coffee,